Right, so the first thing we're going to do here is go to tenable.com/download/Nessus, since Nessus is a Tenable product. We're going to download the software from there. Then we're going to go to our localhost URL at port 8834, which is the Nessus Security SG port. We're going to log in with a simple username and password. I chose Anon and a 16-character password. And then at the top right, we're going to go ahead and click New Scan. As you can see, there's many different kinds of scans, but we're going to just do an advanced scan for now. A little later, we'll show you a basic network scan. Since we couldn't get the Debian box from the DOE competition to work, we decided that we're going to instead just scan Andrew's computer. So here we're entering the name of the scanner. We're just going to call it Windows Scan. An optional description, we're just going to type in Andrew's computer. And then we're going to target the 192.168.1.127 address. And once you've created this scanner, after you click Save, you're going to have to go ahead and launch the scan, which is on the right side over there. And after clicking around a little while, playing with Nessus, we found that you can actually set up a remote scanner, which we thought was pretty neat. So we're going to go ahead and demonstrate how we're going to set that up. You would use this remote scanner if you weren't able to access your local domain and wanted to perform a security scan. So here we are clicking the remote link. We turned it on, named it the same name as the Windows scanner we currently have. Up there we have a linking key, which Andrew will tell you about in a little bit. It's just the key that he provides for us that we can link the scanner to. And clicking Save will give him controls of our scanner. You can use a proxy, but we decided not to.
Okay, so this is the Tenable I/O interface. It's pretty much set up exactly like the Nessus interface for ease of use, so you don't get confused between the two. And we're just going to set up the exact same scan that Henry just showed, just showing that we could do the same thing either on your local host or also remotely from any location. So we're going to enter in the same IP address here as we did before, to stay in the scan machine. So after we click Save, we're going to go and launch the scan the same way that we do in Nessus. The next thing we're going to show is going over to the Scanners tab here on the right, and here you can see the linking key that Henry used to link the two things together. And then here you can see that we are using his Windows scan that he made to scan my computer in the Tenable I/O interface. And here's some network data that you can see while the scan is running, to kind of give you an idea of what's going on with the scan. And this is the alerts tab. We didn't have any alerts though. And this is overview, which shows you how much CPU usage, total megabytes used, and other stuff like that. And now this is the results of the scan. The only major vulnerability that we found was this SMP signing not required. SMB signing was the server message blocking protocol. It's a Windows protocol that is used to share packets between things on the same network. And it can be used for man-in-the-middle attacks if this is not on.
All right, now we're going to take a look at a scan of my home router. So at the top right, we're going to click Start a New Scan. And this time we're going to click on Basic Network Scan. Give it the title of My Home Network. Since I was unsure exactly what my router's IP was at this moment, I went over to the terminal window to type ifconfig. And from there I can see that we are on a 10.0 address, which means that my router should default be 10.0.0.1. So we're going to enter that target in. Once we've done that, we're going to hit Save. After clicking save, we can't forget to launch the scan over on the right. After we launch the scan, we're going to fast forward a little bit to our results. So it looks like here that we have at least 5 critical vulnerabilities and several other small things that we would need to patch if we wanted our home network to be completely secure. Of the 5 critical vulnerabilities we've come across, we see that we have ones with PHP, SSL, and DNS. And if we were to look closer at the mixed PHP issues, we would see that we would need to update PHP as soon as possible to avoid an arbitrary command injection vulnerability that exists in the IMAP open function due to improper filters for mailbox names. So, if you were to leave this unupdated, someone were to exploit this vulnerability, your mail client will stop working, or even worse, have all the data exfiltrated. So this kind of shows you a basic network scan and how great